All right, welcome back. So I know that I said that we were going to be looking at procedural materials, but I want to talk about modifiers and sub-D topology first, because we've been using a couple of modifiers, but we haven't really taken the time to talk about like how modifiers work and looked at some of the common ones yet. So I want to do that before we get into procedural texturing, and in particular the subsurface modifier, because it sort of ties into the way that we were doing proximity loops in the previous video when we were talking about shading. That sort of ties together with subsurf modifier, so it's good to know. And you'll see what I mean. So let's get started. So we've got a cube here. Go ahead and make a cube and then make a duplicate cube. And what I want to do is to show you how the subsurf modifier works. And over here on the right, we have this modifiers panel. And we've used one or two in like the practice videos. We used the solidify modifier when we were making the bowl and the vase, and we've used the subsurf modifier I think as well. But over here on the right, you've got this little picture of the wrench modifier properties. What you can do is just select your cube on the left and add modifier, and we're going to add a subsurface modifier. And you can see that it gets like kind of rounded. It gets sort of the topology gets more dense, it gets more verts, but it also sort of smooths out the mesh. I'm going to change that right now from Catmull-Clark to simple, and then just go ahead and apply this, because I want to talk about how this works. So if you tab into edit mode on this cube, you'll notice it's got twice as much, or twice as many face loops as it did before. So, and actually if you shift click both, you can tab into edit mode to edit multiple objects at once. And you can see that on this cube on the right, we've got a face loop going all the way around the cube like this. If you alt click on this edge, it'll highlight this face loop. And then on this one, now we've got two, right? And so what the subdivision surface modifier is doing is it goes through your mesh and essentially divides all face loops in half. And in that way, it subdivides the entire mesh. So if, for example, on this cube on the right, we were to go and add a loop cut on all of the face loops, right? So a cube has, by default, 3 face loops, one this way, one this way, and then one horizontally like that. If we were to add a loop cut across all 3, you can see that that is essentially the same result as we got from using the subdivision surface modifier. And so that's how the subsurf modifier works. Now the subsurf modifier also has an additional property, which is that smoothing out of the mesh that we talked about before. And it's sort of funny, if you look at the actual Blender documentation on how this sort of smoothing effect works, it says the arbitrary looking formula was chosen by Catmull and Clark based on the appearance of the resulting surfaces rather than on a mathematical derivation. So the Catmull-Clark algorithm essentially smooths out the subdivided mesh according to what they thought looked visually appealing, and this is sort of the result. Now, in one of the previous videos, we talked about how adding proximity loops can affect the way that your model is shaded, and it does that by averaging the face normals across a shorter distance. And in that way, you can, for example, on a smooth shaded object, get sort of a better looking edge by adding proximity loops around that edge, and that will sort of cause the shading to be more defined. The same thing applies to subsurf modifier. So if I have let's make just a normal cube here, just a plain cube, and add a subsurf modifier. And you can see here, if I turn the levels up to 2, it gets a little bit more subdivided. So every face loop is now getting essentially sliced in half twice. So if you had one face loop, it gets divided to 2, and then each of those 2 get divided, so you have 4. So it's adding quite a bit of geometry to your mesh. But if you tab into edit mode and add a proximity loop and drag it close to an edge, you'll see that essentially the geometry gets tighter around that proximity loop. So if we drag this here, you can see here that what it does is it sort of brings that edge back. And if we could do the same thing here and here, you can see that we're able to sort of shape the mesh by adding proximity loops in order to hold those edges. And so if you wanted to, you could make sort of a rounded cube using this technique. Now this doesn't come without a cost. Obviously you're adding more geometry to your mesh, but again, for every face loop that you add, for every additional level of subdivision, that's going to divide those face loops. And so you can imagine if you're adding lots of proximity loops to a mesh and subdividing the mesh a lot, you could end up adding quite a lot of geometry to your mesh. So for example here, if I have this, you can see I have added one proximity loop here around the top, which has created one face loop. I'm subdividing it twice, which means that that one face loop is going to become 4. And I've also got one here. So around this edge, we're going to end up with quite a bit of geometry. So if I go ahead and under this little drop down menu here where this triangle is, just hit apply. And you can see that we've got like these nice square faces around the middle of the mesh, but around where we had those proximity loops, the faces are more narrow and rectangular. And that's because now we've got a lot more dense topology around that edge. So that's something to keep in mind, because sometimes that's okay, sometimes you don't want that, and so you just want to be mindful that if you're using proximity loops, especially on a heavily subdivided mesh, that's going to result in sort of a lot of geometry being created around edges, which you may not want. Now, one thing I want to add about modifiers, and we've used a couple modifiers, but we haven't used a lot of modifiers together on one object. What I want to do is show you what happens when you do that. So I'm going to add a cube, and then I'm going to, in edit mode, drag this over so that its origin point is still in the middle. And I'm going to add a mirror modifier. And what the mirror modifier is going to do is it's going to mirror this object across its origin point, which is this orange dot. If you want to move the origin, just hit Control period. Oops, let me turn on. This keeps turning off. And then you'll see that we're not actually dragging the object now, we're dragging the origin. And this object is getting mirrored across its local x-axis relative to that origin point. So Control period to turn that off, and I'm going to turn on clipping for this example. And what I want to do is just grab these 4 verts, so this side, and just GX to drag them towards the middle, and you'll see that they sort of merge in the center. So that's what clipping does, is when you're mirroring an object sort of across the origin point, when the verts come in contact with their mirrored verts on sort of the mirrored half of the object, they get merged. And the reason we're doing this is because I want to show you the importance of the modifier stack. So here we have a mirror modifier that we've applied, and if I go to the drop-down menu, now I'm going to add a subdivision surface modifier, and you can see that we've got the subsurf modifier below the mirror modifier in the stack. And what that means is it's going to be applied after. So the way that this works is modifiers get applied in order in terms of sort of where they are in the stack, and none of these are applied, right? They're all still sort of procedural. Which means that we can change them dynamically. So I can reorder these so that the sequence or the order of operations that it's doing is different. So say, for example, here, what if we were to subdivide this first before doing the mirror? Well, you can change the order of modifiers in the stack by clicking this. You can see there's this little handle here that looks like 8 dots. If you click that and drag, you can actually move these around, and that can sometimes pretty drastically impact the result. So for example here, if you subdivide the mesh first and then mirror, well, now it's just going to mirror this across the X, but it's not going to clip because those verts are no longer touching each other. So changing the order of modifiers in the stack can affect the sort of the way that your result looks, and they are always applied in order from top to bottom. Now I'm adding another cube here because I want to show you something else, which is that there's actually another technique to sort of preventing that rounding over of edges, and it's called edge crease. So if we go here and we add again, let's add a subdivision surface modifier to a plane cube, and then tab into edit mode, you can see that our because we haven't applied the modifier, our geometry here is still sort of the same when we're in edit mode. So we still have these 8 verts that made up the cube. If I select this top face here, so just the top four edges, and I'm going to hit Control E, edge crease, and I haven't clicked to confirm, but I'm just dragging the mouse back and forth, and you can see that it's creating a crease on that edge. And what that does is it essentially reduces the amount that those edges are going to get rounded over by the subsurf modifier. So that can be a good technique sometimes. So I'm going to drag this all the way up to 1 and then left click to confirm, and then tab out of edit mode, and you can see now we have this object, and our edge was remained flat. So both techniques have pluses and minuses. The plus of the proximity loop technique is that it tends to look better. Unsurprisingly, lots of geometry, tends to give a better appearing smoothness to a mesh, and that's because there are more faces to average normals across, so you get really nice smooth looking shading around smooth surfaces. The minus, of course, is that you're adding a lot of complication to your mesh, which if you're not applying the subsurf modifier, sometimes that can be okay because these modifiers are procedural, right? So I haven't applied this yet in this case, so that means that the geometry of this is still looking like that cube, and so it means that we can always undo it later. Whereas if I were to apply it, that sort of becomes permanent, and you would have to undo the changes that you've made to the mesh manually. So sometimes that can be okay. The pluses and minuses with edge crease are a little bit different. So here, if I right click and shade smooth this object, you'll see that it looks like okay, but it doesn't look that great. And the reason for that is what we talked about in the previous video, right? And so it's averaging these edges over quite a large distance. So for example, this face to this face, right? So this edge is not being rounded just here like it was when we were using the proximity loop technique, but is now being rounded like averaged from here to here, right? And so as a result, we get this shading that looks sort of okay. It doesn't look that great. Now, of course, you can always subdivide the mesh more. So if I were to add a subsurf modifier and turn it up, you can see, wow, we get that like super crisp looking edge, right? Which is, sometimes is what you want. And of course, the reason for that is now we've just got like a crazy amount of verts on this object. This is like super dense, right? So this edge is now being rounded like from here to here. And that's why we get that sort of much crisper looking smooth shading around this edge. Now, if we had done this using the proximity loop technique, we could have just put an edge loop up here like that, and maybe one up here on the top. Inset this. By the way, I inset this top loop. Whenever you inset a face that has a crease on it or a seam, it's going to duplicate that onto the new edges. So if you ever want to get rid of an edge crease, the way to do that is to go Control E, and for like sharps and seams, you'll notice we've got clear seam, clear sharp. I don't know why, but for edge crease, there isn't an option in this menu for clear edge crease. So what you can do is just select edge crease and set the value to -1, and that will get rid of it. There we go. And so now you can see we've got this nice crisp edge on an object, which is still fairly low poly, right? So, and we achieve that by putting this proximity loop here. And so we have, unlike in the previous one, we do have more dense topology on the object, but it's restricted to the areas that we want and not all over the object. Now, that's obviously not, sort of the end of this discussion. There's stuff you're going to learn later on if you keep, sort of sticking with 3D modeling, like weighted normal modifiers and auto smooth, especially if you get into like hard surface modeling. But for now, that's a pretty good overview of like the key stuff that you need to know. Now, before wrapping up, I wanted to just talk about topology for a second, because it sort of ties into subdividing the mesh. So when you use subsurf modifier, essentially what it's doing is it's splitting all of the faces on your mesh into smaller faces. Now, most of the time as a beginner, you want to be using what we call sub-D topology, which is essentially topology that's compatible with subdividing the mesh, which is a quad-based mesh. So you don't want to have tris or n-gons throughout your mesh because they can cause problems with sort of with the subsurf modifier. And I'll show you what I mean. So I have a quad here and I have a tri. So this has 4 verts and this one has 3. And what I'm going to do is I'm going to add a subsurf modifier to this, and I'm going to put it on simple. So it's just subdividing the mesh, but it's not sort of smoothing it. And I'm going to hit apply so we can see what that did to the geometry of these faces. So over here on the left, you can see this divided this evenly, right? So what we've got here is a situation where we had a quad, and it's created 4 quads from this. But over here on the right, we've got a tri, but it didn't create new tris from this. It converted the tri into quads. So now we've got this weird shape, right, where we've got a quad here, and a quad here, and a quad here. And this can cause problems when you try and subdivide your mesh. So for example, if I create a cube, and I put a tri on one of these faces, and let me just do a normal cube as an example beside it, and I'm going to subdivide both of these. So we'll apply a subsurf modifier to the one on the right. You can see it gets nice and smooth, and we have geometry that's going in a clear linear edge flow. So that's all well and good. This one on the left, though, that has 2 tris in it, if we add a subdivision surface modifier to this, you can see that what happens is we end up with this weird situation in here where we've got really messy topology resulting from this. And you can see if I apply this and then go into edit mode, that face here that was a tri has now been divided into quads, but we've got like super weird edge flow. And so if I try to put a loop cut here, you can see this loop cut or these face loops are like just a disaster. And so if you're going to be subdividing your mesh, you want to try and avoid having n-gons or tris in your mesh because it doesn't work very well with subdividing the mesh. Now I want to show you something else as well, which is that non-quad topology is problematic with loop cuts as well. So if I tab into edit mode here, you can see we've got this cube, and if I take my knife tool here, I'm going to push K, and I'm going to slice this face in half. I should turn on screencast keys because it keeps getting turned off. So what I did there was I just pushed K and then click on this corner and click on this corner and then enter to confirm, and that will slice this face between those 2 verts. You notice here, if I try to put a loop cut on this side, this will go all the way around the object, and that's fine because that face loop here, this face loop going around the object this way, is made entirely of quads. If I try to put a loop cut here, sort of on this more face loop that's sort of facing towards us, it's not going to go all the way through the object. And the reason is that the loop cut will not go through tris or n-gons. When we made our bowl and our vase in the previous videos, we saw this with cylinders, because if I go Shift A, mesh cylinder, and add one, a cylinder by default has this big n-gon on the top, where like this has not just 4 verts, but quite a few more. And so if we try to subdivide this, you'll see it's going to create sort of a mess. And that's because it's trying to subdivide this n-gon here at the top. And of course, that doesn't work very well. And so again, like in the previous video, I showed you, there are a couple ways to fix this. If it's a perfectly flat face, you can get away with just insetting it. But again, the weird geometry is still there. So what you can actually do if you want to like actually get rid of it is just X to delete that face, and then re-add it by highlighting the edge loop where it was and doing a grid fill. And now if we subdivide, you can see that that works fine. We have we have sort of a quad-based face on the top. So whereas on the bottom we've got all this weird stretching, now on the top this looks pretty good. All right, so that's it for subdividing the mesh and topology. Now we're going to get on to procedural materials.